Hello my dear students, welcome back to my class. In the series of learning programming in C, in the previous video we had an introduction to dynamic memory allocation. Well, in today's video we will discuss about dynamic memory allocation using malloc. We can allocate the memory with many functions like alloc, realloc, and we also have the free function to free the allocated memory. We will see all the functions with separate videos. In today's video, we will discuss malloc function with a programming example. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. So what is this malloc function? So we have malloc, calloc and realloc. Malloc function is one of the functions that what we use in the C language, which stands for memory allocation. Malloc means memory allocation. It is used to dynamically allocate a block of memory that what we require during runtime, that is during execution time, from the heap memory. And what it is going to do, it is going to return a pointer to the first byte of the allocated memory. So if I am going to allocate a block of memory from the heap memory, say a block of memory is allocated and the address of the first byte is something, it is like 2000. So this address will be returned. So obviously, as I said, when we are dealing with dynamic memory allocation, we have to make use of pointers, because when it is returning the address, pointer is the only variable that can hold the address. So the first byte address will be written and it will be stored in the pointer. So a pointer will, and this pointer allocation will be done in the stack frame. So you will have these pointer allocation in stack frame and this pointer will be pointing to this location. So it is going to return the first byte of the allocated memory. And how to use this? Very simple. This malloc function is used, followed with the size of the memory that what I need to allocate. So we will be deciding how much amount of memory we need to allocate during runtime. So that size we need to specify here. That is the amount of memory to be allocated. And this malloc function is going to return a void pointer. Void pointer means it is generic pointer. So we have discussed about this generic pointer. Please do check out the playlist of C language. Generic pointer is a one, that is void pointer, which can point to any type of location. Means if the user cannot predict what type of value we are going to store during runtime, then we simply allocate a block of memory, and that block of memory can be used to store any type of data. So later we will be typecasting that. So we are going to typecast that, because a generic pointer is a one that can point to the location that can store any type of value. It can store any type of value in that location. So once I say I can store any type of value, so the pointer should be capable of locating or pointing to that location. Later the user can typecast that to the requirement. So how to typecast that, how a generic pointer can point to the location, let us see with an example program. So here we have a very simple program to understand this dynamic memory allocation using malloc. So what we do, we just accept the number of values that what we need to accept, that is n value we are going to accept. So in the output screen, we will be getting a message, enter n. So I have to accept how many values I need to store. So I just say I want to store 3 values. So n value will be 3. Then here is the malloc function. So for that we have an integer pointer. So as I said, malloc function followed with the size of the memory to be allocated. I say n size I need to allocate. N means which is 3 into the size of the data type. So I want to store three integer values. So it may be 2 bytes or it may be 4 bytes, depends upon the machine that what we use. Just assume we are using 16-bit machine, so it is 2 bytes. So size of int means it is 2 bytes. So it is 3 into 2. So totally 6 bytes of memory has to be allocated from the heap frame. So from the heap memory, I need to dynamically allocate how much memory? 6 bytes of memory. So here I am just saying the malloc function has to allocate n into size of the data type int. So size of int is 2. So it is 3 into 2, 6 bytes of memory I need to allocate. So what just forget this. Malloc function, what it is going to do, as I said, it is going to return void pointer, means generic pointer. It is going to just allocate 6 bytes of memory. What type of value I need to store? Later I need to typecast it. It is going to return, say for example, a block of memory is allocated 6 bytes of memory, totally 6 bytes. So it is totally 6 bytes. Later we are going to typecast it. Totally 6 bytes of memory I need to allocate. The first byte address is 2000. So let us assume the first byte address is 2000. So this first byte address it is going to return. So it is a void pointer, generic pointer, and this address or this location can store any type of values. Generic pointer means it can store any type of values. Now this address, that what the malloc function is going to return, it has to be typecasted. It has to be typecasted here. So what I do here, I say you typecast that to integer. So that address will be returned to a pointer which is PTR. So PTR will be allocated in stack frame. In the stack memory, we will have PTR. We will have PTR and this address will be written to this. So now this pointer PTR is pointing to this first byte address which is 2000. Now, so as you should enter the values, I am going to get that message. Enter the values. So hope you understood this. Malloc function is going to return n into size of int. N is 3. 3 into size of int means 2 bytes. 3 into 2, 6 bytes of memory. It is going to return a void pointer which is generic pointer, and this generic pointer is typecasted here. So what we are doing here? We are going to do typecasting. So typecasting is done here. So it is casted to integer pointer. So PTR is of integer type. So this integer pointer will be stored in this PTR which is in stack memory. PTR is now pointing to this location 2000. So later I am going to store that values in that location. So I am going to put a message, enter the values. It starts I equal to 0, I less than n. N means it is 3. So this scanf statement will be executed 3 times. So how it is going to scan the values? Just observe here. I say scan an integer. So I am going to input 20. That integer, I need to store it in PTR plus I. This is what pointer arithmetic. Hope you remember this. If you have any doubts in this, you can just please check out the playlist. You have the pointer arithmetic concept where you can understand how the pointer is going to deal with the location. So here I am not going to use any ampersand because pointer itself stores the address. So what do we have in PTR? It is 2000. So how it gets substituted here? What the compiler will do? It says 2000 plus I. What is I? It is 0. 0 into size of the data type. So what is the size of the data type? It is integer. So I just say it is 2. So it is 2000 plus this is what? Size of the data type. So 0 into 2 it is 0. So it is 2000. Right? So this value will be stored in 2000. So my first value which is 20 will be stored here. So no need to use ampersand here because pointer itself stores the address. I can simply say PTR plus I. So what the plus I will be, how it gets substituted? Plus I in the sense, plus I is 0 into the size of the data type. So it is 2000. Then again look back, I gets increased, I becomes 1. So it is 1 into 2. So it is 2000 plus 2. So the next location, this is 2000, this is 2002. Next value I am going to input, say I am going to input 30. So that will be stored in PTR plus I. That is 2000 plus 2, which is 2002. Again look back, I gets increased. It is 2. So what is 2 into 2? It is 4. So 2000 plus 4, it is 2004. 2000, 2000, 2001 first element. 2002, 2003 second element. The next one 2004. Say I am going to input the next value, which is say 50. So that next value will be stored in PTR plus I means it is 2004, which is 50. So this is how we access the location. Now, after that I can get a message. Entered values are, then I say percentage D. Now look at here. I should say asterisk. Asterisk represents, that is value at the location. It is indirection operator. It is directing to that location. So I can just say it is pointer dereferencing. So it is value at the location. So asterisk represents value at the location. PTR means 2000 plus the loop starts I equal to 0, 0 less than n. So condition true, 0 less than 3. So now I should say asterisk PTR plus I. PTR plus I in the sense 0 into 2 bytes, 0 into 2, it is 0. So it is 2000. So asterisk 2002, asterisk value at the location 2000, it is 20. Again look back, it becomes 1. 1 less than 3, condition satisfied, execute, print an integer stored in asterisk PTR plus I. I is 1. So 1 into 2, it is 2. 2000 plus 2, it is 2002. Now it becomes 2002. Value at the location 2002, it is 30. Again look back, it becomes 2. 2 less than 3, yes. Print the integer stored at the location PTR plus I. PTR, it is 2000 plus, what is I? It is 2. 2 into 2, it is 4. So it is 2000 plus 4. So 2004, the next element, which is 50. So this is how it is going to print the value. So hope you have understood this. Then later, after printing all the values, we need to free the pointer. So this is the malloc function. So this pointer arithmetic concept you need to understand, which is going to calculate the locations. So PTR will be initially 2000. 2000 plus 0 into the size of the data type. 0 into, that is 2. So it is 0. 2000 plus 0, 2000 for the first iteration. Right? Again look back, it becomes 1. So it is 2000. PTR value will be 2000 plus 1 into 2. How much? It is 2002. So it goes on like that. Again 2 into 2. So this is how the pointer gets iterated. So this is how the malloc function can be used. So that's all for today's video. See you in the next video. Till then, take care. Bye-bye.